All right, everyone, welcome back to this solution paper for the GCE mock examination for paper 1, chemistry. So hopefully you guys are well prepped for this examination. Paper 1, usually very straightforward, but the trick with most of the questions is if you can read it properly. So especially for GCE, a lot of the questions, 50% of the mark is understanding the question, and then you look at the options. So as long as you read the questions properly, I'm sure you'll be fine. So how about we just jump straight into our first question. At temperature X, the volume of samples of hexane and pentane are not affected by changing the pressure from 1 atm to 2 atm. So the volume is not affected. So this is important. You always need to make sure you read the question. At temperature X, the pentane molecules are free to move. At temperature X, the hexane molecules are in fixed positions. Whenever we see anything that says free to move, we can assume that this is either liquid or in certain cases it can be a gas. And then over here it says fixed position. So whenever you see fixed position, automatically you know that this is a solid. But here's the thing. Earlier they said that the volume is not affected. So volume does not change. So if your volume doesn't change, then what that means is that you are a liquid. Because we know that when you increase pressure, then the volume of a gas should decrease, right? So if this was a gas, then volume would decrease. So keeping all that information in mind, so we're going to look for temperature X, the pentane molecules are free to move. So we're looking for either liquid or gas. So for that we have, we can cut A and, we can cut A off, there we go. Next we're looking for hexane, which will be solid. So we can cut off this as well. And because we know that volume isn't changing, then we know pentane is a liquid, and so your answer is going to be C. Right, very simple, nothing too complicated. Let's move on. Separate samples of water and air each have a volume of 30 centimeter cube at room temperature and pressure. The pressure applied to both samples is increased by the same amount at room temperature. Which row describes the volumes at the increased pressure? So water, we know, is a liquid. Hopefully we all know that water is a liquid and air is a gas. So as mentioned before, when you increase pressure, the volume decreases, but only for gas, for gases. So the volume of air will decrease. So obviously we're going to cut off 300 because the volume will not increase. And because it's a liquid, liquid volume will not change. Does not change with pressure. Change with pressure. So because the liquid volume doesn't change with pressure, we can immediately, since we know that the initial is 30, we can cut off A, and thus our answer, once again, is C. All right, moving on. The main component of mineral X is calcium carbonate. X also contains tiny grains of silicon oxide. There are no other substances in X. Which row shows two correct statements about X? So they're saying that either X is a compound or it's a mixture. So a compound describes when two or more elements are chemically bonded. Chemically bonded. So the trick over here is understanding that the main component of mineral X is calcium carbonate. X also contains tiny grains of silicon for oxide. So if they were only talking about calcium carbonate, then you could say that that's a compound. Or they're saying silicon oxide, then that's a compound. But because they both exist independently, or you can say that it's a physical combination. Because it's a physical combination and not chemically bonded, this is a mixture. So immediately we can cut off A and B. And next they're saying X contains exactly either 4 or 5 different elements. So let's take a look. Let's use a different color for this. Calcium is 1, carbon is 2, oxygen is 3, and silicon is 4. Remember, oxygen is already repeated. So the answer for this question will be exactly 4 different elements. Remember, they say different, so this is the important thing. Because they said different, we're not going to count oxygen twice. So it's going to be C. A pure sample of element X has a relative atomic mass of 51.8. The sample consists of 3 isotopes. The table shows the relative masses and percentage abundances of 2 of the isotopes. What is the relative mass of the 3rd isotope? Okay, so the way this goes is you take your, it's going to be percentage times MR1, so percentage 1 times MR1 plus percentage 2 times MR2, and then this goes on, and this will be divided by 100 to get the final MR. So this is equal to the final MR. So if we keep that formula in mind, what we're going to get is 40% times, don't include the percentage, by the way. If you do that and you put that into the calculator, you're going to get a completely different answer. So you're just going to use the whole number that's mentioned here. So don't write, do not input the percentage sign. Just making sure so that nobody makes a mistake. So 40 into 50 plus 20 into 55, and this is going to be divided by 100 plus, okay, I'm going to need some more space for this, so we're going to keep that, and I'll just erase this. It's a problem with these papers. You don't really get that much space for working out. But I'm pretty sure you can ask for a blank piece of paper in the actual exam, so you don't need to worry about that too much. How about if I just write a bit smaller? So how about over here? So 40 times 50 plus 20 times 55 plus, and the remaining percentage will be 100 minus 40 minus 20, which is 40, because these two together is equal to 60. So this will be 40 times X. And then you divide all of this by 100, and this will equal to 51.8. So if you do the math, you'll get a number that comes to around 2,000 plus 1,100 plus 40x is equal to 5180, because you're doing cross multiplication. So 40, so then you bring all those numbers to that side, so you're going to have 5180 minus 3100, and you're going to divide this by 40, and so x is equal to 52. Again, let me just make sure that I've done my calculations right. Divide by 40, yeah, and that is 52. So the answer is invariably 52. I think I'll use a fifth center for the next few questions. All right, moving on. The table shows data about 2 isotopes in a sample of the element europium. So again, we use the same formula as before, so this will be percentage 1 times MR1 plus percentage 2 times MR2, and we're going to divide all of this by 100. So this will be 150.92 times 47.81 plus 152.92 into 52.19, and then you divide this by 100, and doing the math you should get 151.9638. And if you look at our options, we have one that's 151.96, and that's your answer. All right, the structure of hydroxylamine, NH2OH, is shown. Which row about hydroxylamine is correct? So, total number of electrons in the molecule. So let's figure it out. So if you want to figure out the electrons, because this is not an ion, so electron number is equal to atomic number. So the number of electrons is, let's count how many hydrogens. We have 3 times hydrogen, which is, if we take a look at the periodic table here, hydrogen is 1, so this will be 3 times 1. You have 1 nitrogen, 1 times N, which is equal to 1 times nitrogen is over here, 7. And you have 1 times O. And oxygen is right beside nitrogen, which is 8. 1 times 8. So this will be 3 plus 7 plus 8, which is going to give you 18. So the number of electrons is 18, so you can cut off these two. And now we're looking at how many number of electrons in the bonds of the molecules. So if we do a dot and cross diagram over here, let's give X for nitrogen. Let's do circles for hydrogen. And let's do green for oxygen. Because remember, they say that in the bonds of the molecule. So you're only going to count the number of electrons in the bonds. So that's 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to 8. And so your answer will be C. All right, moving on. Which compound has the highest relative formula mass, Mr? So we have a bunch of the ARs given, so we just need to calculate the MR for each. So it helps if you write down what each of them is. So you've got calcium carbonate, CaCO3, lithium sulfate. This is Li2SO4. Because remember, a sulfate ion is -2, a lithium is +1, so you need 2 lithiums to counteract -1. Then you have magnesium chloride, MgCl2. Same deal, magnesium's +2s, and this is only -1. And potassium nitrate. Potassium nitrate is very simple, KNO3. All right, so let's figure out the molecular mass. So calcium carbonate is 40 plus 48 plus, I should tell you how we got 48, plus 16, because they've already mentioned O is 16, into 3 plus 12, so this gives you 100 even. All right, next, lithium sulfate. This is equal to, lithium is 7 into 2, plus sulfur is 32, plus oxygen, which is 16 into 4. So if you do the math, that gets you 104. So that looks to be our prime candidate. Let's take a look. Magnesium chloride, very simple, 24 plus 35.5 into 2. So that's going to give you 95. And lastly, potassium nitrate. This is, potassium is 39 plus nitrogen, which is 14. plus oxygen 16 into 3. So that gives you 39 plus 14, 101 even. So your answer is lithium sulfate because it has the highest. It's 104 compared to everything else. All right. Powdered calcium carbonate reacts with dilute hydrochloric acid to produce calcium chloride, water, and carbon dioxide. What is the correct ionic equation, including state symbols, for this reaction? So first of all, you're starting with powdered calcium carbonate. So whenever you see anything powdered, that means that it's going to be in the solid form. So automatically you can get rid of anything that's saying that calcium and carbonate are in the aqueous form, because they are not. So we're going to start with calcium carbonate in its solid form. To produce dilute hydrochloric acid to produce calcium chloride. So what's going on to the calcium ion is it's going from a solid state. So it's going from calcium this to calcium aqueous. So we 2 plus 2 electrons, and these 2 electrons are chlorine. So this will be chlorine, CO2 plus 2 E minus to give you 2 chlorine ions. So over here, this already says calcium chloride to aqueous. This isn't really giving us the ionic equation because we know what ions are liberated, so we can also get rid of this, thus leaving us with B. It's because you need to know what ions are being involved within the reaction, right? So that's why we really can't work with, let's say, calcium chloride, because it's not really telling us what ions are being liberated over here or what state changes are happening, right? And also, we don't really know what the form of the calcium chloride is, so we can't really say that this is. Well, to be fair, no. When you're getting an ion, it's obviously going to be in aqueous form, so we're looking at that. And obviously, calcium chloride, the hydrogen ions are being over here, solid is going from aqueous, and everything else is sort of the same. All right. Next question. A mixture of sodium hydrogen carbonate and sodium chloride is heated. The equation for the reaction that takes place when sodium hydrogen carbonate is heated is shown. 2NaHCO3 gives you Na2CO3 plus carbon dioxide plus water. Sodium chloride is unchanged on heating. When 6 grams the mixture is heated, the loss in mass is 1.5 grams. What is the percentage by mass of sodium hydrogen carbonate in the mixture? So the trick for this question is realizing that the loss in mass is both due to carbon dioxide and water. So this 1.5 grams has a total MR of both H2O plus CO2. So that means that when you're calculating the MR, it's going to be 18 plus 44, which is going to give you a value of, let me put that into my calculator, 18 plus 44 gives you a total MR of 62. So the number of moles lost is going to be 1.5 divided by 62. So this will be 0.02 moles. This is a very important part of the question to realize, that because this is in gas and this is also in gas, you need to count for both of them to be lost within the mixture. And it's impossible to tell which one will be carbon dioxide and which one will be water when they're being evaporated. So you need to consider that they have a combined MR, and you do your calculations that way. So the molar ratio is 2:1:1. So this will be 2:1. So for every 1 mole of water and carbon dioxide lost, you need 2 moles of sodium hydrogen carbonate reacting. So to find out the moles of sodium hydrogen carbonate, it'll be 2 times 0.02, which is 0.04 moles. And now we need to figure out what the mass of this is. So 0.04 times the MR of that. So this will be 0.04 times the MR of sodium hydrogen carbonate, which is 84. And that's going to give us the original mass, So this will be 84 times 0.04. Yeah. So once we get that value, and then you divide that by 6, and 1 second, I have to just be back real quick. Okay, so the trick with these types of questions is you never round out too early because that's going to cause a lot of changes within your answer. So what we're going to do is we're going to keep this value as it is. So let's keep this value 1.5 into 1.5 by 62. Divide by 62. So 2 times 1.5 divided by 62. So that's going to be 3 by 62. So this will be 3 by 62 into 84. The reason you want to do this is that whenever you round out too early, you're going to get different values. So the value I was using with 0.02 or 0.04, it resulted in the answer being significantly less than what it was. So if you use 0.04, then your answer would come up to 56%. But when you're using this value over here, 3 by 62, the value that you're going to get over here is, so 3 by 62 into 84 gives you 4.06 grams. And when you divide 4.06 by 6, the answer you're going to get is 68%. And if you use 0.04, then you're going to get 56%. So remember to use the raw value in calculations. All right, let's move on. Magnesium reacts with aqueous copper 2-sulfate to form copper and aqueous magnesium sulfate. What is the correct equation for this reaction? So we're dealing with copper 2-sulfate. So whenever you see this symbol over here, the 2 over here means that this copper has a charge of 2+. So if it has a charge of 2+, and sulfate has a charge of -2, so the copper sulfate is going to look like CuSO4. So immediately you can cut off B and you can cut off D. And let's see what we're dealing with. To form copper and aqueous magnesium sulfate, it's the same thing. Sulfate and magnesium have the same thing. So it's not going to be Mg2SO4. So by process of elimination, your answer is going to be A. The diagram shows the electrolysis of molten lead bromide with inert electrodes. Which row identifies the particles that carry charge along each arrow? All right, so remember that charge within this entire circuit, within the circuit, charge is carried by electrons. It's carried by electrons. So that means that over here in 4, it's going to be an electron. At 1, it's going to be an electron. At 2, it's going to be electron. So anywhere you see that there is not electron for 1, 2, and 4, so let's say 1 says bromide ions, that's going to be wrong. For 2, all of them say electrons. For 3, we'll get to 3 in a bit. For 4, over here they say lead ions, it's not going to be that. So our choices are between C and D. Now, over here it says molten lead bromide. So whenever anything is molten, that means that it's going to be PbBr2 liquid. So the charge carrier over here is, so because it's liquid, that means that there's no hydrogen ions or no hydroxide ions, so no H plus or OH minus. So charge carrier is ions. Charge carrier is bromide. Or ions, actually, is ions. So because it's going to be ions, it's going to be C. And we're going to cross this out because this says electrons over here. Because over here, there's no electrons being liberated. It's just the ions that are carrying charge. Over here, ions carry charge. All right, moving on. A mixture of 2 grams of hydrogen and 32 grams of oxygen occupies a volume V measured at RTP. The gases react until there's no further change. Which reactant is in excess, and what is the final volume of the mixture measured at RTP? So it has a molar ratio of 2:1. So let's find out the moles of H2. So this will be 2 grams divided by 2, because H2, so this will be 1. And moles of oxygen is going to be 32, and O2, so this will be 32. So this is 1. So the way this goes is that this says that 2 moles of hydrogen react with 1 mole of oxygen. But we don't have 2 moles of hydrogen, do we? We have 1 mole. So oxygen is in excess. So your oxygen is in excess. So you can immediately cut off A and you can cut off B. And now they're talking about the final volume measured at room temperature and pressure. Because you're going from a gas to a liquid, your volume obviously decreases. So let's figure out exactly how much does the volume decrease by. What is the final volume of the mixture measured at room temperature and pressure? So you have 24 dm cube of hydrogen and 24 dm cube of O2, because 1 mole and 1 mole. So it's mentioned over here at the bottom of the periodic table. The volume of 1 mole of gas, of any gas, is 24 dm cube at room temperature and pressure. So the total volume is 48, and from 48 it goes to, so you use up all 24, so it'll be 48 minus 24, and half of that, so minus 12. So you're going to be left with 12 dm cube. So 12 by 48 is equal to 1 by 4, and so your answer is going to be C. The apparatus used to investigate the electrolysis using inert electrodes of dilute sulfuric acid and concentrated aqueous sodium chloride in separate experiments. Which row shows the ratio of the volume of gas collected in each test tube? So we're investigating the electrolysis of dilute sulfuric acid, H2SO4. So the way the reaction goes is you're going to have 4 hydrogen ions becoming 2 moles of hydrogen gas. And for oxygen, because you're releasing 4 electrons, you're going to get, for each oxygen, you're going to need 2. So it's going to be 4 electrons needed for oxygen, so it's going to be twice that of hydrogen. Yeah. So for oxygen, the way it's up, because you've got 4 O minus, those 4 electrons gives you 2O2. Ratio volume of gas in X and Y with dilute H2SO4. X is to Y. No, wait, 1 second. Let me just take a look at this again. H2SO4. So for sodium chloride, because it's concentrated, let's take a look at this first. Because it's concentrated sodium chloride, the only gases being liberated are going to be hydrogen and that. So this is going to be in a 1:1 ratio. Because you're dealing with, because it's concentrated, you're not liberating hydrogen gas, you're liberating sodium. And over here you're getting oxygen, so this will be 1:1. And over here, when you're dealing with H2SO4, it's really the same thing. Just give me 1 sec. Right, sorry about that. All right, so let's begin with H2SO4. So for H2SO4, the way this goes is you're gonna have 4H plus, you're gonna have, 4H plus 4 electrons is gonna give you 2H2. And over here, you're gonna have 4 hydroxide ions that are gonna turn into O2 plus 2H2O plus 4 electrons. So the ratio over here is going to be 2:1. And because you're dealing with concentrated aqueous sodium chloride, instead of having OH being liberated, no OH, it's going to be Cl minus. So again, it's the same thing where you're going to have 2 electrons plus 2H plus to give you H2. And these 2 electrons come from the electrolysis of 2Cl minus to give you Cl2 plus 2E minus. So those 2 electrons go over here. So Cl2H2 is 1:1, and this is 2:1. So this answer will be C. There we go. A reaction pathway diagram is shown. So we can tell by the shape of the curve where the final energy is higher. So reactant energy of products is greater than reactants. So this is an endothermic reaction. Endothermic reaction. So because it's endothermic, it usually means that there's a lot of bond breaking happening. So because there's bond breaking happening, we're going to look for a reaction that shows bonds being broken. So this is bond formation. Bond forming. This is just state change. So no real energies over here. This is also bond forming. And over here, you're breaking bonds. So this is going to be bond breaking. And as a result, process of elimination, we cut out everything except B. All right, the diagram uses apparatus to investigate 2 different reactions that produce gases. So 5 grams of solid X and 100 cm cube of 1 mole per dm cube hydrogen chloride. The reactants for each experiment are mixed, and the mass of flask plus contents for each experiment is recorded every 30 seconds. A graph of the mass against time is drawn in experiment 1. Solid X is calcium carbonate. So calcium carbonate plus hydrogen chloride. This liberates calcium chloride plus, this will be 2HCl. And because you've got carbonate, this will be carbon dioxide plus H2O. And over here, when you add HCl to this, 2HCl, you're going to get MgCl2 plus hydrogen. So in experiment 1, you're producing carbon dioxide. Experiment 2, you're producing hydrogen. So which one is heavier over here? Hydrogen has an MR of 2, and carbon dioxide has an MR of 12 plus 32, so 44. So this is heavier, so CO2 heavier. So when you're losing more CO2, your mass will decrease more. So the mass of experiment 1 is going to decrease more than the mass of experiment 2. So we're looking for that. Experiment 2 shows that less mass decreases compared to experiment 1. So our answer is going to be C, as CO2, experiment 2 is hydrogen H2 lost, lighter. And over here, experiment 1, CO2 lost, which is heavier. This is a very interesting question, honestly. Lost, heavier. So weight decreases more. decreases more. Which statement about reactions is correct? A reaction in which the number of bonds broken equals the number of bonds formed always has an enthalpy change of del H 0. This is not true. This depends entirely on the enthalpy values. So let's say you break 2 bonds of hydrogen and you're forming 2 bonds of hydrogen chloride, even though the number of bonds broken are equal. So let me just write down, for those that won't watch the video and we'll just consult this, not always true. Combustion can be either exothermic or endothermic. Not true. Combustion is always exothermic. In exothermic reactions, the thermal energy is transferred to the surroundings, so the temperature of the surroundings increases. Yeah, but let's take a look at D before we calculate. The activation energy for a reaction is the minimum energy particles must have in order to collide. No, that is not true. Activation energy is the energy required for successful collisions. So this is not correct either, so the answer is going to be C. Let me do a proper circle for that. All right, 17. In 2 separate experiments, 1 and 2, an excess of powdered calcium carbonate reacts in a flask with dilute hydrochloric acid. In experiment 1, the volume of carbon dioxide is measured at regular time intervals. In experiment 2, the mass of the flask and its contents is measured at regular time intervals. The results of both experiments are plotted on graphs. So for W, you see the volume increases, then stops at 1 time. So now they're asking us which graph shows the results of these 2 experiments. Excess of powdered calcium carbonate reacts in a flask with dilute hydrochloric acid. The volume of carbon dioxide evolved is measured at regular times for experiment 1. So obviously, we have an excess of powdered calcium carbonate reacts in a flask with dilute hydrochloric acid. So the limiting reagent is HCl. Limiting reagent HCl. So as a result, the graph should flatten over time. Flatten over time. So because of that, we can immediately cut out Z and X. So any answer that has Z and X in it is going to be wrong. So Z together. Our answer is A. The pH of dilute ethanoic acid is measured. The equation for the partial dissociation of ethanoic acid is shown. CH3COH turns into CH3COO minus plus H plus. Aqueous sodium ethanoate, CH3CONA, is added to dilute ethanoic acid and the pH is measured again. What is the initial pH of the dilute ethanoic acid and how does it change after the addition of the aqueous sodium ethanoate? So initial pH, immediately we can cut off 8 and 9 because these are alkaline. Alkaline. So we're looking between 3 and 4. After adding aqueous sodium ethanoate, so CH3COONA, this turns into CH3COO minus plus Na plus. So you're adding more CH3COO to the equilibrium mixture. So when you're adding more of this, equilibrium will shift back towards this way. Will shift towards the left-hand side. So when you're shifting towards the left-hand side, you're also causing a decrease in H plus ions. And H plus is responsible for pH. Responsible for pH. So if H plus decreases, then acidity decreases. And so pH increases. So 18 answer will be A. Diagram shows the change in pH as a strong alkali is added to a weak acid. 40 cm cube of a strong alkali is added to a weak acid sample solution set separately with methyl orange. Alright, so let's first write down the color changes for all of these. So methyl orange. So for methyl orange, when it's acidic, it's red. And when it's alkaline, it's yellow. Alkaline means yellow. And for thymolphthalein, if the pH is alkaline, then it's blue. Alkaline or greater than 9.3, then it's blue. Otherwise, it's colorless. So 40 cm³ of strong alkali is added to a weak acid, and a sample of the solution is tested separately with methyl orange and thymolphthalein. 40 cm³ of a strong alkali. So over here, we're looking at 40 cm³. So the pH is going to be around 13-ish. So if it's around 13-ish, our thymolphthalein will be blue, and methyl orange will be yellow. So we're looking at that where we're seeing blue and yellow, and thus the answer for 19 will be D. All right, let's move on to the next question. The equation shows the reversible reaction between nitrogen and hydrogen to form ammonia, and 2 plus 3H2 gives you ammonia. Forward reaction, so that means this reaction is exothermic. Which statement is correct? When the temperatures increase, the activation energy increases? No. The equilibrium shifts to form more ammonia? No. Equilibrium shifts backwards. Equilibrium moves backwards. So this is also wrong. The rate of the forward reaction decreases? No, it increases. It increases. And the rate at which ammonia decomposes increases. So yeah, I mean, we eliminated all of the answers. So, and this is also correct. So 20 is D. The formula of hydrated sodium carbonate is Na2CO3 10H2O. What is the percentage composition by mass of oxygen in hydrated sodium carbonate? So let's do the math. 3 times 16 plus, and then you've got 10. So this will be 10 times 16 divide by 3 by 16 plus 10 by 16, plus you have 2 sodium, so that'll be 23 into 2, plus 1 carbon, which is 12, plus 10 into 2 into 1. So if you simplify it, it comes out to 208 by 286, and then you do that into 100, and the final value comes out to 72.7%. The answer is D. Part of the periodic table is shown. W, X, Y, and Z are not the correct symbols of the elements. Which statement is correct? The compound formed between X and W has covalent bonds. Nope, because this is group 1, group 2, group 3, 4, 5, 6, and this is group 6, so they form ionic bonds. W and Y are both gases at room temperature and pressure that contain covalent bonds. Yeah, this seems correct, but let's take a look at what we have below. X and Y react together more vigorously than Z and Y at room temperature and pressure. So this is saying that X and Y react more vigorously than Z and Y. That's not true. Z reacts more vigorously. X and Z both have 2 outer shell electrons. That's not true because it's group 1, so they only have 1 outer shell. So process of elimination, our answer is going to be B. Which statement is correct? Noble gases are unreactive because they all have 8 electrons in their outer shells. This is not correct because helium has 2. The group 7 element, acetine, is expected to be a black solid at room temperature. If you take a look at the periodic table, acetine is right below iodine, and iodine is a black solid, so this could be correct. Let's take a look. The reactivity of the elements in both group 1 and group 7 increase down the group. That's not true. In group 7, it decreases down the group. And when aqueous chlorine is added to aqueous potassium bromide, there's no change in color. That's not true. It decolorizes. One second. Decolorizes. So, answers B. All right. 24. Elements P, Q, R, and S are in either group 1 or group 6 of the periodic table. P is a liquid at room temperature and pressure. Q is a gas at room temperature and pressure. Elements R and S, so if P is a liquid at room temperature and pressure and Q is a gas at room temperature and pressure, then that means that Q is above P. So down the group, Q is above P. Elements R and S both form basic oxides. Element R has a higher melting point than element S. So that means that S is above R in the group. So for the most reactive, vigorous reaction, you need the one at the bottom for group, this over here. So you need to match with, so it needs to match, let me do this on the periodic table. So the most reactive reaction that happens here will be between francium and this group 7 and fluorine. So that's the way you're going to have to match this. So in the same way, if R is below S and Q is above P, so R and Q have the most vigorous reaction. So 24 is going to be, oh, I'm so sorry. What am I saying? No, that's fine. Element R has a higher melting point than element S. So yeah, this will be R and Q. Q is a gas at room temperature pressure, P is a liquid, yeah. So 24 will be C. All right, let's move on. Oh, actually, see, this is why I don't rush into questions. I was rushing into this question and I completely missed out over here. Element R has a higher melting point than element S. So that would place it actually above S. So the way this goes is actually going to be, because they form basic oxides, it says that these are group 1 metals. And in group 1, MP decreases down the group. So it'll be R and then S. So if you go down, it'll be S and that. So the answer actually is going to be D. So my apologies for that. So let's move on. Which elements are the major constituents of brass? This is fairly simple. It's going to be copper and zinc. M is a metal that forms colored compounds, so that means this is a transition element. Transition metal. So this is a transition metal. We can get rid of anything that says magnesium. M is extracted from its oxide either by heating with carbon or by electrolysis, and M reacts with dilute hydrochloric acid. So by heating with carbon or by electrolysis and then reacts with hydrochloric acid, these are all symbolic of iron. And so that's going to be 26D. The iron 3 oxide used in the blast furnace contains the impurity silicon oxide SiO2. Which reaction removes the silicon oxide? So this is, as long as you're well informed about the procedure that goes on in blast furnace, you shouldn't have any problems with this. You need calcium oxide. Calcium oxide removes it by turning it into slag. So this will be 27C. Chlorine and carbon are both used in the treatment of the domestic water supply. Which row describes one reason for the use of each substance? So chlorine is used for killing microbes, so you can automatically get rid of A and B. And carbon is used to remove odors and taste from the water. So it's not going to remove dissolved oxygen from the water. It's just going to do that. So 28 is C. Nitrates and ammonium salts are used as fertilizers. Which fertilizer contains the greatest mass of nitrogen in 50 kilograms of the compound? So the way you're going to do this is, I wish I had like a blank page to do this on. So let's start with NH4Cl. NH4Cl. Ammonium is 14, so this will be 14 plus 4 plus 35.5 times 50, not by 100, because you're trying to figure out in 50 kilograms of the compound. So when you do this, you're going to get 13.8 kg. Next, for NH4NO3, this will be NH4NO3. So this will be 14 into 2 because there's 2 nitrogen over here. So again, that'll be 14 into 2 plus 4 hydrogen plus 3 into 16 is, what is that, 48, times 50, and this will give you a value of 17.5. So NH42SO4, let's do that over here, NH42SO4. So again, you have 2 nitrogen, so this will be 28. This will be 28 plus 8, because there's 8 hydrogen plus sulfur plus oxygen 64. So you do this into 50, and it's going to give you 10.6 kg. And the last one, potassium nitrate. This will be 14 divided by 39 plus 48 plus 14 and a 50, and together that gives you 14 kg. So 14, so the highest is going to be NH4NO3. Which statement about alkanes is correct? Ethane reacts with chlorine in an addition reaction. Nope, addition reaction means you need a double bond, and there's no double bond, so this is correct. Propane has a higher boiling point than butane. Nope, it's has a lower boiling point. So double bond needed. For here, the molecule of the alkene that contains 99 carbon atoms has 200 hydrogen atoms. So for alkane, it's CnH2n plus 2. So if n is equal to 99, this will be 99 into 2 plus 2. So 99 into 2 is 198 plus 2 is equal to 200. So yeah, actually the answer is C. Nice. And there are 3 isomers in the formula, C4H10. We don't need to go any further. We already know that the answer is C. All right, 3 statements about global warming and greenhouse gases are listed. Global warming is occurring because more of the Earth's thermal energy is released to space. That is not true. Global warming basically acts as a blanket. So let's say if this is the Earth, and this is like the layer of greenhouse gases. So we're not having enough heat being released to space, so it's sort of bouncing back, right? So the heat is bouncing back. So any one that has 1 is incorrect. So your answer is going to be D. This is heat. Alkanes undergo a substitution reaction with chlorine. Which row shows 2 correct statements about the reaction between alkanes and chlorine? 32. A carbon atom is replaced by a chlorine atom. The reaction requires thermal energy. No, a carbon atom is not replaced by a chlorine atom, so this is incorrect. Hydrogen atom is replaced by chlorine atom. This is correct. The reaction requires thermal energy. No, this is not true. This is sort of it doesn't require thermal energy, it requires UV. So this is also incorrect. Carbon atom is replaced by chlorine atom. This isn't true, so this is going to be final answer. Let me just underline what's wrong with this. Carbon atom This is replaced by fluorine. Same thing over here. Cool, moving on. 33. Copper 2 oxide reacts with dilute ethanoic acid. Which equation for this reaction is correct? So the first two you can immediately cut out because this has a charge of -1, but copper has a charge of +2, so this needs to be 2. So A and B is going to be out. And then we're taking a look at the other ones. There's no hydrogen gas being liberated over here because there's oxygen over here, so it's going to be incorrect because H2, where's the other oxygen? So this is going to be correct. And ester has the structural formula CH3COO CH2CH2CH2CH3. What is the name of this ester? So let's take a look at how it's formed. So CH3, it's a CH3, COOC. So the the acid over here has 2 carbons. So this is going to be ethanoic acid, and the alcohol is going to be propanol. So it's going to be propyl ethanoate, 34C. 35. P is a branched hydrocarbon with a ratio of carbon atoms to hydrogen atoms being 1:2. P has a relative molecular mass of 56. So we're going to have to count sort of the number of... first, we're going to have to find out ratio of carbon atoms to hydrogen atoms being 1:2. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So not 1:2, so we can cut off A. Over here, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2. So this is 1:2. So we can keep that into consideration. This one, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 6, 7, 8, 9, 10. So this is not 1:2. So we can also cut this off. And this one, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1:2, but now we get to the second part, which has the relative molecular mass of 56. But the problem is, because there's 1, 2, 3, 4, 5 carbons, 12 into 5 is 60. So this MR is higher than 56. So we can cut this off, and our answer is going to be B. The structures of X and Y are shown. What is the structure of the polymer formed when X and Y react together? So let's take a look over here. So the amide bond is going to form between this part over here and it's going to form between this part over here. So we're going to have to look for something where... Okay, so first of all, we can immediately get to this because this is saying CH2,4, and then you get the amide bond. Where did this sort of come from? So this is not correct. Again, over here, CH2,6 suddenly has a carbon atom over here, so this is also not correct. Let me replace the box over here. The box should sort of cover which part is wrong. So this is also wrong. This one looks correct, and HCOCH24, and then sort of this suddenly has a nitrate group over here, so this is also wrong. So the answer is going to be A. Solid J contains cations and chloride ions. The aqueous solution of J is colorless. 2 separate samples of the solution are tested. Aqueous sodium hydroxide is added to the first sample and produces a white precipitate. Aqueous ammonia is added to the second sample, produces a white precipitate. All right, so for this one, as long as you remember your cation and anion test, this shouldn't be too difficult over here. So in case you guys don't have the table, if you're giving your paper 4, then you should take a look over there. And if you're giving paper 3, then you just take a look at that. But for the sake of this paper, I'm just going to explain which one is correct. So let's take a look. The cation in J must be aluminum. So it says, the problem with this question is it says must. So it's not must, because this could also be zinc or calcium. So this is incorrect. The cation in J must be iron. Again, we're getting white precipitates. So iron is always, there's a different color for that. Iron is always green precipitate. So not iron. Oh, yeah. When dilute nitric acid and then aqueous barium nitrate added to an aqueous solution of J, a white precipitate is formed. So this test over here is for sulfate ions test, but this explicitly states that there's chloride ions in this, so this is not correct. And this is the chloride ions test. Chloride ions test, so this is correct. All right, last two questions. Samples of two compounds P and Q are tested. The result of each test is shown. Add dilute hydrochloric acid. Gas given off that turns lime water milky. So immediately we know that this is going to be carbon dioxide. So anyone that does not talk about carbonate ions, so A and D is immediately out. So we need to take a look. Oh, wait, over here this talks about a lilac flame. So lilac flame, I mean, since we've already eliminated basically A and B, remaining two has potassium. So let's take a look at Q. So Q is talking about green precipitate. So the thing about green precipitate is it can either be chromium or iron 2. So how do you distinguish between the two? Because this is saying that it's insoluble. Anytime you see in aqueous ammonia insoluble, that means that this is going to be iron 2. So the answer for green precipitate is, oh sorry, so this is insoluble, that's fine. This could be iron or chromium. But over here this says soluble in excess. So this is the main thing. Chromium is soluble in excess aqueous sodium hydroxide. So your answer is going to be C. All right, 4 samples are analyzed using paper chromatography. P, Q, and R are pure substances. So pure substances means no other substance or element. M is a mixture of different substances. So let's take a look at M. M correlates with Q, M correlates with P, but not with R. So which substance does mixture M contain? So, and then there's also one spot over here, but because we don't have it on the chromatography sheet, so this is the correct answer. 39 is going to be P, Q, and another substance. And the last one, a chromatogram, a mixture of X and pure substances P, Q, R, and S are shown. Which statement is correct? R is completely insoluble in the solvent used. That's not correct because it moves above baseline. Moves above baseline. R value of Q is greater than the R value of S. Let's take a look. So yeah, because the height measured for Q is more than the height of R, this could be correct. Let's take a look. X is a mixture of Q, R, and X, Q, R, and S. So that's R. That's Q. But they also say it's a mixture of Q, R, and S, but it's not matching with S. So it's not going to be this either. For the solvent above the baseline, that's never true, so your answer is going to be B. So yeah, pretty straightforward paper. Maybe some parts of it were a bit tricky, but as long as you paid attention to the questions and you didn't panic, I'm sure you guys will do fine. So yeah, best of luck for your paper 1, and after that, be sure to give yourself a well-earned break. You guys have been studying incredibly hard, and yeah, you guys deserve it, and best of luck with the exam, and best of luck especially for A-levels. So this has been Alba for Fastpapers, wishing you guys best of luck, and see you soon.